Greetings, class. Mr. Munir here with your daily robotics lesson. I'm here now on Coder Z. You should have already finished Plains and Hills 1 and 2, and so now we're moving on to cruise control. All right, so let's take a look. I've actually already run through these just to see how they are before I record this video. So you're going to see me restart the mission each time I run through them, but here's the deal. You're going to do these first 4. I'm going to talk to you about doing quick to the block, and you'll do that one on your own, and then you'll do speed bump 2. So again, I'm doing 4, then you'll be responsible for finishing 2, though these last 2 are actually really easy, so it should take you no time at all. All right, let's get to it. So first, we're going to go into speed limit. All right, so I have to restart the mission just so it gives me those prompts because I want to read those as you will see them exactly the same way. So it's loading. All right, again, you're not going to have to reset it because you're just walking through it the first time. All right, speed limit. Drive Ruby slow enough to avoid colliding with the bad container in front, but fast enough to escape the one behind her. The bad containers will start moving forward slowly when the button is pressed. Okay, cool. Click here to open the heads-up display so you can see the readings of Ruby's sensors. Use the manual control feature of Explore mode to control Ruby with the arrow keys on it. All right, so all I care about is speed, so I'm just going to open that up. And then in order to do manual control, I just go ahead and do this, and this is run faster. So if you're running your code and you're just annoyed because it's taking too long, you can do that. This changes the angle, that changes distance. Okay, cool. But I'm interested in manual control, so I'm going to set that up. And I can just go ahead and hit play. And actually, I'm not sure if I even need to hit play, but I'm just going to go ahead and use my arrow keys. So I use forward to start my little guy going forward. And then as soon as I hit that button, notice, oh man, the block is coming to get me, so I have to avoid it. So I have to kind of keep hitting that forward button in order to avoid that block hitting me. And cool. All right, so that's kind of just like a video game, so that's kind of fun. So that's easy. The only thing is you have to know how to do manual control, which I just show you how to do. All right, next activity. Do 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 do. All right, so again, I've got to restart because I already did this one. So restart. You won't have to do that. It'll just set it up for you like usual. All right, for this mission, Ruby needs to do the same. Ruby needs to do the same as in the last mission, this time with code. Ooh, fun. This is the if-else block. It's built to check if Ruby is driving under 75 centimeters per second. If she is, Ruby sets motors to 100. Otherwise, Ruby sets motor powers to 0. Okay, what does this mean? This right here is an if-else block. You're going to find this in Control Flow tab. And how this works is just like an if conditional that we learned about in Robot C. So if the robot speed is less than or equal to 75. So get robot speed returns the speed of the robot. So think of it like a sensor. It's if the sensor of robot speed, if it's sensing that the robot speed is less than or equal to 75, do this. And if it's more than 75, do this. That's what else is. Do this, else do this. Okay, so if the motor speed is the robot speed is less than or equal to 75, set motor power to 100% for both left and right. That means if it's going too slow, you turn the motors out to 100% and it'll keep going faster. Then if it's going greater than 75, that means it's going too fast, set the motor power of left and right to 0. That means it's just going to cut the motors off. It'll keep rolling. It's not like it's hitting the brakes, but it's going to gradually slow down because of friction. Okay, so if it's going too slow, do this. Turn the motors on. Else, which means it's going too fast, turn the motors off. Okay, that's the way that works. But something is still missing. Until when does Ruby need to check her speed? Can you figure out what's left to add? Well, okay, I got this. All right, so let's just drag this up and see what happens. I'm going to hit play. So compiling, compilation successful, run simulation. Okay, so notice this lit up, but it only lit up once. That's because it just checked it once, right? And why? Well, because I only have this program running through this code from top to bottom. So what that means is it's just going to check this once, and then it's going to do whatever it needs to do, which obviously the motor's robot speed was less than 75 because it was stopped. So it checked that. It said, okay, well, it's lower than 75, less than or equal to 75, so turn the motors at 100%. And then it just finished, and it didn't give it any other commands. It didn't give the robot any other commands, so the robot just kept going. The motor powers just stayed at 100% motor power, which eventually made the robot accelerate too fast, to too high of a velocity, and it hit the block. So I don't want to just check this once. I want to continuously check this over and over, because sometimes I'm going to be going too fast, sometimes I'm going to be going too slow, and I need to check this over and over and over again. Well, how do I figure that out? I go to control flow. Now, I don't want just to repeat this one time, and I could actually change that number to repeat 1,000 times, but I want this to be able to check over and over and over and over again. So what do? Repeat forever. Okay, so repeat forever is just like a while loop, like while one. So it's always going to be true. It's just going to keep repeating over and over and over and over again. So that's helpful. So then I just put this whole thing, I click and drag this whole thing and put it inside there. Cool. So repeat forever, do this whole thing. So it's going to check again and again and again. So now that I've got that, I reset my simulation. Let's hit play and let's see what happens. All right, now look, it's lighting up over and over and over and over again. Cool. So it's checking it again and again and again and again and again. And notice that my robot is speeding up and slowing down. Cool. All right, nice. I did it. Sweet. That was fun. Okay, so that was the second activity. We finished it. We did it with code now. And we saw how we used code to automatically control something that we were doing before with our arrow keys. All right, what's the next challenge? Ooh, this is fun. All right, again, I've got to restart because I've already gone through this, but you don't have to do that step. We'll just set it up right away with the prompts. Okay. This time you need to build the condition by yourself. Ooh, a challenge. You can find the if block in the control flow category. Okay, search for the math block here in the data category. Finally, you need to get robot speed block from the sensor category. Okay, so that explains everything right there. Nice. All right, the power values and speed values are different from the last mission. Okay, so I'm not just doing the same thing. So first, I'm going to bring my if in, and I'm going to put it where it's going to belong. And so I wanted to put it in this repeat forever. Now notice, this is just if this is true, do this. There is no else. If I want an else, I have to hit that plus. So if this is true, do this, or else do this. So if this is not true, if that's false, you're going to do the else statement. But what if I want an else if and then an else? I just hit plus again. Look, oh, if this is true, do this. Else, if, so I can have another if conditional there that's checking if something else is true, do this. And if none of those are true, you're going to do that final else thing. So remember, this is that conditional if, else if, and I can have as many else ifs as I want. I can keep adding, right? So I can check all these different things, and if none of these are true, it's just going to do that final thing. But I only want to check two things. I want to check if the motor speed, remember, so get robot speed. I want to check if the robot speed is less than or equal to, I don't know. I need data again here, so to bring a number in, I can't just type numbers in. So check if motor speed is less than or equal to, I don't know, let's say 60. Okay, if robot speed is less than or equal to 60, what do I want to do? Well, I want to, if it's less than or equal to 60, I want to set my motor's power to 100. And else, that means it's more than 60, I want to set my motor power to 0, right? I could potentially hit the brakes, but that might be a little too drastic. Like you'd speed up and then hit the brakes and you'd slow down so rapidly that it would kind of be jerky. And you can test that out if you want. But let's see how this works. Okay, here we go. I've hit the button. I'm going pretty quickly, but then I get going up this hill, I start slowing down. Okay, cool. This looks like it's working. Looks like I'm gonna get nailed. Oh, I got nailed. All right. I still won, but I lost points. So my motor speed is not correct, so I'm going to try that again. Okay, so I'm just going to change the speed because obviously that was too slow. So I'm going to make it, let's make it 70. Make it 70. And so I've already reset the simulation because I hit try again. So let's try 70 and see if that's going to work. Okay, it's looking good so far. Oh, am I going to get hit again? Looks like I'm going to get hit. Oh, okay, cool. So I still got hit at the end, but who cares? Uh, at this point, I could try it again. I could increase my speed. Sure. It looks like I didn't get the full point, so I do want to get the full point. So let's make it 80. Let's try that again. Let's try 80. And then I don't want to wait all this time, so I'm going to do run faster, and I'm going to hit play. So let's see if I can make it with 100 points this time. Oh, nope. See, that was too fast. Okay, so there you go. All right, so I already accomplished this, but you can test it out again. I'm not going to keep going back and forth, but you can see that you can go too fast, you can go too slow. You got to get it in that sweet spot right in between. Who knows what that is, but I didn't get 100 points. Maybe you can. And notice that's what those bad blocks do. They take away points. And remember, this is a competition at the end of it. So, okay, I've got to restart the mission. So I'm now on the, I think I'm on the fourth. I'm now on the steady climbing. So what is this one? Then this time we need to deal with different inclines, uphill and downhill. Before coding, think carefully about how to code a cruise control code that will work going up and going down. Can you make sense of the blocks here to solve the mission? I'm on it. All right, so they've already given you the blocks, so that's helpful. All right, so I think like the way to think about this is just if I'm going uphill, I want to be increasing my speed. If I'm going downhill, I want to be decreasing my speed. But if I don't have any motor speed at all and I'm still going downhill, I'm going to keep speeding up. So it's not going to help me just to like turn the motors off because I'm going to keep speeding up because I'm like rolling down the hill. And so I need to do something more, which is, of course, hit the brakes. Okay, so I think that's pretty clear. It's not too much of a guess. So the if statement goes here. If the condition rather goes there, if robot speed is less than or equal to, I don't know, let's try 70. If robot speed is less than or equal to 70, um, now like notice how these comments work. So I can have this comment in here, it's not gonna actually change anything. So um, going uphill we can speed up. So if it's less than or equal to 70, I can speed up, right? Else, if it's greater than or equal to 70, um, I want to brake. Okay, so now technically this is going to brake regardless of if I'm going uphill or downhill. So like I don't really know that. That's kind of a little bit of a false comment here. Um, so it's really not we're going downhill. This is more of just we're going too fast. We're going too fast. Okay, but since I am going to end up going downhill here, I need to speed up. So this really is just I'm going too slow. So speed up. And this is we're going too fast, hit the brakes. Okay. So the only reason why we're hitting the brakes here is because that downhill. Yeah. Okay. I already said that. So let's hit play and see what this is going to do. Okay. Let's hit the button. It's going uphill. Looks like it's getting nailed. It's about to get nailed. You see how it's hitting the brakes and it's just getting annihilated? That's not fun. Okay, so when it hits the brakes, it slows down pretty rapidly. So that speed of 70 is just too slow. So I'm getting hit, so I need to change that speed. Let's make it 80. Reset simulation. And then go ahead and hit play. So I've hit the button. It's looking good so far. Oh, nope. I got annihilated. Still didn't work. Okay. So let's make it 90. And reset simulation. So obviously this is something that you've got to play with, and you've got to, this is something you'd see in real life too, is, unless you know mathematically in advance exactly how fast you're supposed to go based on your situation, then you're going to have a situation where you're going to have to just adjust. So, okay, this is the last time. If this still doesn't work, I'm going to just let you play with it. So I'm going to go for 100. Just go full throttle, shall we? And hit play. Okay, so I completed the mission. I still got nailed, but it still worked. So as you can tell though, like I was still going too slow. So you're gonna have to play with that to find a better speed than 100. But I still completed the mission, so I'm gonna keep moving forward. Again, this is a competition, so it's I shouldn't say it's a competition, but I will award the ones that get the most points at the end. So you do want to try and get the most points. You don't want to just complete the mission and say that's that. Um, you want to try and get the most points. All right, so now this is where I'm going to leave you, but I'm going to talk you through it first. Okay, now we can use the set wheel speed block to control speed as opposed to power. You can find the set wheel speed block here in the movement category. We can use this block to be more precise. We're going to need it in the next missions. Got it. Okay, so the reality is the way that we were doing it was kind of inefficient. I mean, if you think about it, I'm just changing the motor power. But what if there was a way that I could change the motor's speed? Well, that would be much better, because if I just have these blocks going at a constant rate, then all I have to do is set my speed to a certain rate, accelerate up to it, and stay there, and then I'm good. I don't have to constantly be checking, making the power more or less. It's kind of in an efficient way and a less precise way to do it. If I have sensors and the ability to set my motor's speed rather than my motor power, then it's going to make a whole lot more sense. And that's exactly what they've given us the opportunity to do. So you can see I have motor power, but I want to just set the wheel speed. And there's things called encoders that you can figure this out. And there's calculations and sensors and ways that you can figure out how fast your wheels are turning. And there are ways to do this in modern robotics. And so this is a very real thing to be able to do to set your wheel speed. So if I just go ahead and go in movement, set wheel speed, I've got it set to 100% right now. So let's see what happens. Boom. I was going way too fast. Okay, so there you go. My speed was way too fast. I ended up, I think, driving off a cliff. So that's not going to work. So obviously for this one, you're going to have to change the wheel speed, slow it down. You don't want it to be 100%. And then you go on to the next one and you'll find it's remarkably similar. So these are probably the easiest challenges that you're actually going to have to do on your own in terms of challenge pack. So I already did speed limit, cruise control, uphill scuttle, steady climbing. I didn't. I did this by myself, quick to the block, but those are the ones you're going to have to do. Quick to the block and speed bump you're going to have to do on your own. So that's your assignment, is to finish quick to the block and speed bump. And I've shown you how to do all of these. So it's up to you to get these two done on your own. And the goal is to get 100% on all of them to make sure that you're getting all the points. Okay, so now that you finish this video, I suggest you go through and uh, do the Coder Z missions, and then finish these last two. Again, you're just going to need, excuse me, set wheel speed for this one, and you'll find that you need it for this one as well. So that's it for me for now. I hope you've been enjoying this. Until next time, enjoy robotics.